Good morning all. Today, this week was somehow tough week, the last week, here in the Fraser Valley. Many families, they have to leave their homes because of the flooding, and even though who didn't leave his home, however, some families, they don't have power supply, and it was a very tough week. I hope that now most of you and most of the families that live here, their situation is more stable, and hope that who has already left their homes will be back very soon, because leaving your own home that you live for a very long time, it's not easy, and you will not feel comfortable if you will be out of your home till you will be back. Concerning the course assignment, had already published assignment 3. I said in my email that I canceled assignment 4, which is because at the beginning of the semester we have already planned to have 4 individual assignments. However, since 1 week we can't have courses, and also I have already extended assignment 3 to more 1 week because of the whole situation. So this is why I said, okay, I will cancel individual assignment 4, and it will be a good opportunity that you will focus more in the project. And also in the assignment 3, I didn't ask you like real case scenario, because I see that you have a project now. You go ahead and apply all the real case scenario on the project. So the assignment was more comprehensive comparing to the all 2 individual assignments. Concerning project, based on the guidelines that I have already published, I said, good morning, Genevieve. I said that this project, I already published some topics, but I didn't go detail in each topic, just it is a topic, which means that I will leave for each group to extend the requirement or to define their own requirements, details. So without any approval from my side, so go ahead and in your report, when you finish your project, you have to go and talk about the project scope and different requirements based on which you have already developed your project. So if you have already choose one of the topics, no need to send me an email for approval. Just if you choose out of the list another topic, go ahead, just send me an email to be sure that this topic somehow will be in the same level like other topics that has already published in the guidelines. So if you choose one of the topics, no need to a pre-approval from my side. Just go ahead and you can work without any approval from my side. And I was very flexible. I don't want to make so much restriction. I will keep it for you to see what is the scope, what the different requirement, detailed requirement and system specification that you want to make analysis and design. Final point in this topic, it's about the presentation. There will be a percentage from the overall grade assessment, or the grade of the project, or the project assessment will be based on the presentation. Why? I believe that if you really have already done this project by yourself, then you can present it in a very nice and a correct way. And if you can't present it, then it is not your own work. So presentation means that you have already done this. This is the first point. Second point, presentation, you should practice work or project presentation during your study in the university, because later, when you go to the market, I have seen this many times, that many students, fresh graduated, when they have to go to the market, they are very nice students, and also or fresh graduated, and they have a high mental capability. However, because they didn't practice how to make a presentation or a talk, especially technical presentation, so when they have to go to an interview to tell about themselves, they will have a bad evaluation because they don't have this presentation tips or skills. So this will be a good opportunity for you to present your own work in a good manner. And again, I will give a grade for the presentation. And the presentation should be done by the whole group. It's up to 10 to 15 minutes, not more. So you as a group, you can go ahead, if you be 4 or 5 members, you can go ahead, each one will take part from the presentation and go ahead and present it by himself or herself. So I will keep it for you as a team, how to present and what is the material you have to present. But I expect if I will watch your presentation, I can understand your project in a very general overview. Plus, I can see different diagrams. Maybe if you have already mentioned in the presentation, talk about why you do this. Again, not more than 15 minutes. You can have it more, but I prefer that to keep it in within 15 minutes. It will be better and more professional. Today lecture, it is now 10th today, and we will have another lecture. Maybe I will summarize the course and I will finish with the course material next week. The week after will be an open stage for presentation. I have already sent in my guideline that you can either, who can join the live session, can go ahead and make a presentation, recorded it with the other team and share with me the link. I will check it later. Or you can join the live session and make a live presentation. Maybe the live presentation sometimes help you. If I have any question or explanation, I can go ahead and ask you during the live session in order to clarify it more. But I know that since it is a synchronous course, many of you, they can't join the live session, so it's up to you. So if you can join the live session, go ahead. The last week, there will be no material. Just it will be open stage for the groups that you are going to present. If you cannot, then you are going to share with me a video about it. And if you have any question about the deliverable of the project, it's your own work. I will not support you in this stage. I will just, if you have more clarification about the project deliverable, go ahead and drop me an email. But again, it's your own project, how you are going to develop this. I will be happy to answer your emails, like always. Before I start, Sarmanjit, Polkit, Janvi, do you have any question concerning the project and the assignment about the deliverable of both of them? If you don't have any question, just give me one thumbs up. So Samranjit or Pulkit, if you don't have, yeah, go ahead. Okay, perfect. So the last lecture today, we will continue about how we can transform the design that we have already developed to a code, to implementation. The lecture was the last lecture the week before the last week. We start talking about how we can this design that we have already finished, how we can transform this to an implementation. Even though maybe the scope of the course, maybe it's more about analysis and design only, but I see that it's good that we can see how this design can transform this to a code without going so much detail in the implementation, because it's not a programming course. It is just more analysis and design. However, it's good to know how this link or how we can make this mapping between the design, that it was an output based on the analysis that we have already done, and the implementation. So the last time we talked about the design class diagram, because we said that the main output for the design was design class diagram that we have already developed based on different analysis we have already, and design also going from the use case to the business model, and then the domain model. Then we have to go to the interaction diagram, like sequence diagram and calibration diagram, till we reach the final design class diagram. And yes, in the last time we talked about how this can design class diagram, different classes and different association we have it, and multiplicity, how we can transform this to a code. To be honest, after I review this and I see that it will be nice to review some OOP Java programming. But when I talk about OOP programming, it's either it will be Java or C++. Somehow they are very similar. We talk that the main difference between C++ and Java and object-oriented, that in Java they don't have the concept of pointers, and if you want to point to another object, you have to use a reference, which is another object pointing to it. However, all other concepts concerning inheritance and polymorphism that we talked about, we will review it today. They are all the same on most of the OOP programming, because it is more an OOP concept that different higher level language they have to follow up if they should be an OOP programming language. So finishing the classes, the design class diagram, how we can transform this to implementation. And I said that there is state of chart. We also, because the two main output will be the class diagram that talk about different classes and different association. And maybe it has the object diagram with it, because to see this some objects, how let's say some object or class instance, how they can the behavior for them. However, the state chart will give us the life cycle of the object behavior. So the input of implementation will be two things: the design class diagram and a state chart that talk about different status for different objects for a given classes, plus the life cycle for this. So we are expecting that after we finish the main classes and association, we are going to go to the state chart and to add more code to our project. However, before I go to the state chart, I just want to review to be sure that some OOP concept you are familiar with it. Again, I expect that most of you, they have already finished the OOP course, so you should all familiar with it. So we talk about inheritance and polymorphism. Polymorphism, which is the main topic of OOP programming. And I talk about it, I give some examples in Java how it is. Again, it is out of the scope of the course. However, I see, or I believe that it will be nice to review them to understand more about the transfer between the code, between the design and the code. Again, it is out of the scope of the course. It is not a programming course. You will not be asked to write a program in this course, just to understand the concept. So we will review the OOP Java programming concepts, the main concept, then we will go to finish the implementation or transform from design of the implementation of the state of chart. So let's start with the OOP Java programming concepts. Yeah, all of us know about inheritance. That inheritance can be whenever you start with the main class, then you can have different subclasses. And these classes, we will be more specialized, which means that, like I said, living things, non-living things. When we talk about living things, we talk about animal and planet. So animal and planet, both of them, they are from a living things. However, there are more specific attributes for this subclass comparing to the main class. So we will be more specialized. And when we talk about inheritance, for sure, we talk that the subclass will contains all the properties and the methods of the main class, plus more special parameters and maybe more special, let's say, more special methods or behavior. So this is why when we talked about specialization, we go to subclasses. When we talk about generalization, and this terminology, generalization, we see it in different places. When we talk about having a global class or different classes, or having a global instance which is related to a global class for different instances, we talk about generalization in this case. So just I'm refreshing your mind about this. So Java is different from has a. Which means that when we talk about inheritance, we talk is a. So when we talk about A is a subclass of B, so A is a subclass of B. Dog is a mammal, hence a dog can inherit all mammals, that it has all the properties and all the muscle of mammal plus specialized properties. However, when we talk about has A, and we have already seen this when we talk about aggregation and composite aggregation, if you remember this, when we talk about the class diagram. So has A mean that like a car and the engine? A car has an engine, which has apart from it is an engine. However, this engine, it is not a subclass from the class, it is apart from a class. So it is a stand-in. When we go to implementation, we will make a standing alone class for this, because it has its own parameters, its own behavior. So it is apart from the A class, but it is not a child from the A class. This is why we talk about aggregation. We differentiate between it, aggregation and inheritance, when we talk about it in the design class diagram. So we are here, when we talk about inheritance, we talk about more is a. It is a subclass, it is a child, and it will have an object instance from this in this case. The main motivation of inheritance, why we need to have inheritance when we talk about what is the strength of inheritance, because you can write a code structured one, but from the beginning we have already started in this course object-oriented analysis and design. So object-oriented analysis and design mean that we expect that we are going to use object-oriented programming. We said from the beginning, from the first presentation, I remember this, we talked about object-oriented analysis and object-oriented design and object-oriented programming. And we talk about that in the analysis and design, we have to use object-oriented, which we are going to deal that to model all the concept you having here as different classes, and we will have different objects, and we have to study the behavior of these objects. So it can be a structured one, because in programming you have two different procedures, object-oriented OOP, or a structured or procedural, they name it, which based on the function without go to the concept of the classes. So, but what is the importance of inheritance? It is the reuse of the code and the reuse of the concept, reuse of the code. Yeah, because for example, if you will have a method that you have already, because when we talk about programming or a function, you are going to declare and define the function, then you are going to call the function. So declare and define, and then you call it. So sometimes the same function, you can call it in different places. So rather than each time you will go to another class or another file, like when we talk about programming, and go ahead and re-implement or redefine the function again, so you can define it in one place, and then you can call it in any place where you want. Just you have to create an object instance from the class where it's being declared, or an object instance from a subclass from this class. So in this case, we are using the code in different places rather than each time we need the same procedure or the same function, go ahead and define and declare. So we said reuse the same reuse of the code. And also reuse the same concept, because sometimes, yeah, the same concepts, which when I talk about the same concept, then again we need different instance from this. We can use it in different places in our code because we are talking about a project that will have maybe hundreds of files and hundreds of places you are going, or tens of places you are going to use the same procedure or same function. So reuse of the code as a concept, one of the main motivation having inheritance. If you will go to go with the procedural one or the structured one, we don't have this privilege. And in this case, you can see that there are some, let's say, code redundancy, because you are duplicating the implementation in different places in this case. So this is why people, they have to go to OOP programming, they have to do it. But however, again, if you want to go to OOP, then you should have already made the analysis and design based on this, because you can't, in order that you can start like we did, that we finished the design class diagram, which is the main deliverable for the design. if we didn't do this based on the OO at design, we can go ahead and make our implementation. So they should be all homogeneous. You will have the same, we name it here as a technical term, the same ecosystem. That you should have the same ecosystem, which means that the analysis and design and the programming should somehow compatible with each other. So if it's from the beginning, you know that we will go to use OOP, so you should make your analysis and design based on OO concept. And this was the main motivation for such kind of courses, that we expect students, they have already learned programming language, but we should help them to learn more how to make a systematic analysis and design. Because according to the software design life cycle, like we use here in this course, unified process, or any, even though if you use the classical water flow, the old one, software development cycle, different phases in your development cycle should be somehow compatible with each other. So to go ahead and make the OOP programming, you should have already started with OO analysis and OO design in this case. Class inheritance, we know that when we talk about inheritance, we use a terminology extend. And if class A is subclass, extend, which means that in this case, B is a subclass of A, and all the protected and public members of the subclass can be accessible by the extended class. We'll talk about the public and protected because we said that, you know, that from the, we talked about it the last time, about protected and public and private access for the different attributes and methods. So if we have in the subclass defined some variables as a public and protected, for sure we will go ahead and do it. We can use them in the extended class. So this is very important when you talk about inheritance, to be well aware about how we make the access, let's say access restriction for different attributes in the class, because if you expect that this attribute will be used, don't go ahead and declare it as a private. So most of the time you are going to declare it either public or protected, and maybe protected will be used more to be sure that this attribute will be used only within the class and all its subclasses or children in this case. So the main aim from this review part of the OOP is I want to talk about polymorphism, because based on my old experience, always a student, even though they finish the OOP programming, I said this is out of the scope of the course, but to be honest, when I start preparing this lecture, I feel that I need to be sure that even though this course doesn't talk about OOP, it talks about OA and OOC, but I want to be sure that you and all students understand this concept in a very correct way. Because many students, based on my old experience, sometimes they know how to use this code in this manner, in this let's say, in this way or in this circumstances or in this environment. However, they don't understand the concept behind this, why you are doing this. So polymorphism, for example, many of you heard the word about override and overwritten and overload of a method, but many of you doesn't know that it is because of the polymorphism. And if I ask many students, what do you mean by polymorphism? They said, what? Ooh, what polymorphism? So the point that I want you to understand more about this concept polymorphism and how, because it is, I said, this is the main motivation for OOP. OOP, we said it is the reuse of the code. So sometimes you want to reuse the code with slight update of the code by the child, which means that a child can be used the same method of the parent or can make some update for the method. So polymorphism will give this privilege. Pulkit, are you still here?
Yes, I'm still here.
Can I ask you a question?
Yes.
Do you know about polymorphism? Can you help us in this?
Yes, I do know some stuff about polymorphism.
Go ahead.
So suppose like polymorphism is basically means like a class. Suppose if you have a class called shape, and it computes area, then you can have different classes that can be like a triangle or a circle, or like a specific class like a triangle, circle, or a polygon, because indeed they're computing the area, but every class or every shape has a different formula. So the base class will be an area class, but then it can have many forms such as triangle.
You mean, let's say we talk about an area as a method or as an attribute?
That's an attribute.
Okay, so what you are saying is correct. You are saying that you can have in the, let's say, in the base class or the parent as an attribute, we name it as area.
Yes.
And each child can has its own definition for this area, or its own definition, or the way it calculates this attribute.
Yes.
Yeah, this is 100% correct, which means that polymorphism will give us mean that we'll have many forms, because it is a Latin word that come. Thanks to you so much, Paul Kate, about this. It is let's say it is a Latin said polymorph. Poly mean many, and morph mean forms, which can you mean that you will have many forms that talk about many forms for the same things, which we, let's say, let's talk about, when we talk about poolkit, talk about area, maybe let's talk about calculating the area. Let's say that's the method. So calculating the area that will give us an output, an area can be this. The way we calculate the area, it can differ, which means that we'll have different forms for the implementation of this method that is being already defined in the basic class. So the main concept is one entity providing multiple implementation or behavior, something like avatar or something like this, whatever it is. So here we can see, like, for example, Peter Packer. I think that most of us know him. Just I found this example a long time in the internet about, it's a very nice example about what you mean by polymorphic. Somebody else has already used it, and it was a good example for the students, which that we can say this actor is a polymorphic, which means that it can has different functionality, even though it is the same concept or the same entity. Yes, because sometimes he will be a school student, sometimes he will be Spider-Man. So which means that it can has different behavior for the same entity based on the environment or the usage or the way you intend to use what has its own attributes and its own method. So we can say this is polymorphic in this case. So Java and polymorphism, it's allowed to define the same method name to multiple different things, overloading. It's allowed child class to redefine, override behavior of the same method, which is overriding. So we will have the concept of overloading and overriding. And this is because we have a polymorphism. So in this case, so we will have two types of polymorphism. We say compile time and runtime. Compile time, which means method overloading, and runtime polymorphism. What we said, compile time, which means that you can any software, when you are going to compile it and then you are going to run it. Sometimes when you compile it, it will create the different classes, whatever it is, and make this compilation for them. And make the executable files. However, when you run time, there are some output you can get it, you can see it in the compilation. We know all of us should know this. So let's talk about method overloading. However, let's define what we mean by signature for a method. So when we talk about signature of a method, which means, like, for example, there is a method we have already declared in any class, integer add, take integer x, integer y. So the signature of this method in this case can set this one. Signature mean how many variable we will have and the type for this variable. It doesn't talk about the name of the variable and doesn't talk about the return of this method. We talk about the argument. We talk about, when I tell you what is the signature of this method, we're talking more about the argument, the input parameters, the arguments. How many and what is the type? We don't talk about the type, the name of this, because the name doesn't matter for us. So, and we doesn't talk about the return type of the return for this method. So this is why having this polymorphism, we can have different signature for the same method. What I'm doing now, I'm focusing about the terminology word, the abbreviation, the terminology. You as a student, you as a software engineer, as a computer scientist, as a computer programming specialist, whatever it is, the title that later you will have. Again, one of the points that also, because I have to work in the industry in parallel with my academic work. So, and sometimes I was under the recruitment committees for more than one company. And I can feel the student will go to make this work interview. They know what this means, but they don't have the technical terms or the technical terminology or the abbreviation. And this will give you a bad point. Because you should, doesn't mean you should be very systematic, because we're talking about science. And you should also memorize the terminology and how it is being used. So many students said, okay, overloading, overriding means that I can have different implementation, and sometimes I will change the argument or change. But do you know what is a method signature? Is that what? Signature? So this is why you as a student, you should somehow be very familiar with different technical terminology that you are going to use later. I'm giving you these advices to help you later when you will graduate to get a nice job and don't suffer so much about getting what you dream to have. So again, the signature will be in this case about what is the attributes and what is the type of the attributes in this case. Okay. So let's talk about method overloading now. So method overloading, that, for example, you will have a class account here. And in this class, you can define different constructor. A constructor is a method that we will use it later to create an object instances or different instances from this class. So you can have different signature for this method. So we name method overloading in this case, which means here, this is the first signature. There is no parameter. Another signature, we will have a 3-parameter string double. So method overloading mean you are not talking about the implementation now so far about inside the method. We talk about the signature of the method. So we will have different signature for the method in this case. Again, we will have different signature. So during overloading is resolved as a compilation time. So when you compile this method, when you compile the code that contains this function that you prepare to be executable now, that later you can run it. So should it's as a compilation time, okay, this method, we will have method, the same method, or let's name here account or the constructor here. The compiler will now understand that it can has different signature, which means can be called using different signature. And later in the runtime, you can run it using one of the signatures, because the compiler has already defined different signature based on your code. So in the compilation time, the different signature will be defined for the same method. This is when you name it overloading in this case. And it should be defined in the compilation time by the compiler to prepare later for executing, that when this method is going to be called in any places, it can use a different signature. You should define it at the beginning, that how many signatures you are going to have for the same method in this case. So what about method overriding now? So method overriding, for example, we keep the same signature. However, now we will see that about the inheritance, how we can use this. In the inheritance, we said in the overloading, we can define different signature for the same method in the same class also. But it seems that different signature, but however, in overriding mean that by the time you can make overriding and overloading. But we want to talk about overloading and then we talk about overriding now. So overriding, which means you define a method with maybe different signature or you have only one signature. And then you will go to the subclass, and you are again going to redefine the implementation of the same method or the same signature in this case. It's the same one we talk about to pull case examples that give it to us about how we can estimate the different rectangle, which means that different subclass can have its own implementation for the same method, the same signature. So this is, we name it, like here, for example, here you have an employee class, and then you create a manager that extend an employee, which means that in this case, manager now is a child and this is a parent. And you have already have a rise salary that has a double by person, which means that a signature has a one double argument. What we do here, we keep the same signature. However, here the implementation said that this mean equals salary plus salary times percent divided by 100, the percent that we get it from here argument. Here, before we will update the percent by a bonus 200, and then we will go to give the final output for this method. So we said here in the overloading, we talk about more about the compiler. So the compiler has to define different signature, and later when you run the software, you are call one of them. In the overriding, you can see the impact when you call them, because during the compilation, the compiler defined that we have only this signature, which taking a percent. We don't have another signature for this method. So the compiler said, okay, we have this method, have this signature. However, it is more related to the runtime. When we will run this two methods, then in this case, we will have different output because we have different implementation. This is why we said the overloading, it's more about compiler, it's about compiler polymorphism. This is the second one, talk about compilation time. It's about runtime. So you can see the impact during the runtime, not during the compilation time. Because in the compilation, you compile the method to check that the whole code, the compiler is correct. What is the signature? If they have more than one signature. In this case, the two methods have the same signature. So the compiler doesn't define new signature for this method. However, during runtime, you will have a different output. So it is more a polymorphism related to the runtime in this case. Also, like here we will, when we run it later. So again, how the compiler during the runtime know which implementation it has to use is depend about the instance. So if it is calling the method using employee instance, then it will go to here. If it is using a manager instance, it will go to here in this case. So for sure, we will have here two different output based on the different implementation that we have already defined it here. And this will happen again, it is during the runtime after we run these methods, because the output will be based about the instance that you will use it to run this method, not only comparing when you define this method. You define it in different classes. However, during the runtime, based on the instance that you use it to run this method, you will get the specific output, and your compiler can know which output you should get based on which instance object you have already used in this case. So polymorphic assignment and casting. This is the last part about polymorphic. We shall talk about overriding and overloading. This is the main 2 points about it. Method overriding. I want you just to be familiar with the terminology and the concept and how to use it. The last point about polymorphic assignment and casting. What I mean by that suppose you have the classes that we have so far seen, the employee and manager. So you create an instance from E from employee and M from manager. This is a parent class, and this is based in this definition, and this is a child class. So if A extend B in general, so A is a child and B is a parent. And any instance of A can act as an instance of B. So you have A, you have B. So if you create an instance from A, it can also act an instance from B, which means that you can go ahead and go ahead and like here and do it like and call maybe a special attribute, or if you will that in B, because it is somehow child of B. So, however, like here, we said, and also, now see this, B can have an A. So we said again, don't forget, A extend B. So B the parent, A the child. Normally you will go say A, small a, equal new A, and B, small b, equal new B. However, we can have this set B equal new A, but with different restriction. We will talk about it now. So if A extend B and B extend C, A extend B and B extend C. Does A extend C? Genevieve or Simranjit, are you here? Simranjit, are you here?
Yeah.
So my question is, if A extend B and B extend C, does A extend C also?
Yes.
Yes. So if I'm a child for my father child for my grandfather, so I will have some properties from my grandfather. Maybe I will be more look to my appearance will be more similar to my grandfather than my father. Yeah.
No.
No. I said if I am a child for my father, and my father is child for my grandfather, so I should have some properties from my grandfather. It
But
happened normally.
it will be more similar to kind B than.
It depends, by the way. As a human being, it depends. Sometimes no, sometimes yes, it depends. So, but so in this case, if A extend B and B extend C, so A extend C. You agree?
Yeah.
Yes, this is correct. In this case, so we can create using constructor of A using an object from type C in this case, because A now extends C. Do you agree?
Yes.
Okay, I have a question to you guys, and maybe for others who are going to watch this video. There is some restriction inheritance in Java. Do you know what it is about multi inheritance? Anyone know about it? Polke, Janvi, or Samranjit?
In Java?
Yeah.
Yeah.
Go ahead.
Multi-level inheritance is not allowed in Java.
Yeah, good. But we said here A extend B and B extend C, so we'll have different level. What do you mean by multi-level in this case? You are correct. You got my question?
I would say specifically like the diamond problem is not allowed. Like
Yeah, this is the diamond problem. You are 100% correct. Yeah. So in this case, as Poolcat said, that in this case, the diamond problem is not allowed, which means that when I talk about multi-inheritance, doesn't mean that we will have different ancestors. No. So A extend B, and B extend C, as we said, and C can extend D. But for example, A cannot extend B and C like this. Do you agree, Polkit?
yes.
So why they have this restriction? Because you will have sometimes conflict with different implementation. So if B, because B and C they don't have inheritance between each other. So for example, if you have a method add in B, define it in a way, and you have another method in C, define it in a way, and then when you A inherit B and C in this case, both of them, so which implementation for add will be used by A? So this is why they in Java they don't have this diamond or multi-level inheritance. We said it. However, you can have this level A, B, B, C, but you will have a single inheritance, not multi-inheritance at the same level. So in this case, like again to here, we can, so based on this, if there is some inheritance, we can use the type of an object from another class or the super class to create an object from the child class in this case, so far what we have already discussed. I'm sorry, I'm asking too many questions. I'm sorry for this. Polkate, can you tell me if there is, before I continue on this polymorphic assignment and casting, can you tell me if there is any solution for this in Java? If I need to do something like this? Do you want me to help you?
Maybe create it as an interface.
Perfect. Yes. Because we can have a multi-level of, in this case, but however, you can use interface. So can this B and C in this case can be interfaces. So I can do this because in interfaces, you define a method, but you don't define implementation. So in this case, you will not have a problem that we talked about, is that you will have two different implementation and then A will be confused which implementation to use. So in interface, you will not have this problem. So Java, in this case, if you want to do it, you have to use interface. And then later you can make you can implement the interface after you use multi-level inheritance when using interfaces in this case. Yes, we can use interface. Thank you so much, Polkit. That's good that we are revising this. Again, I said this is out of the scope of the course. However, it's very nice to revising to understand more how this design will be related to Java implementation. Maybe I should have already done this before the class, how we make the design class diagram implementation. However, I think, okay, if even though I didn't did it before, let's do it now before we continue the stage off. So let's go to this, the final talk about the polymorphic assignment and casting. So now we have this scenario. We have class student and we have undergraduate and graduate. Both of them extend the student. So both of them you will have here, like here, you have a student and you have undergraduate and you will have here a graduate. Two child from the parent class student. And each one, it has its own constructor, and maybe they will have a method like here, toString, makes this overriding for the method toString, having the same signature but different implementation. So the rule now said that the right hand assignment should be a subtype of the left hand assignment, which means like this. Here we will have student S1, S2. Don't forget, we have student, graduate, undergraduate, which means that we create an object here, not from a graduate, undergraduate. We created two different objects from a student. And so this is correct. This is a polymorphic assignment, and this is correct. Why? Because the right hand assignment, which is this here, sorry, this here, the right hand, is a subtype from the left hand. So this is a restriction that I talked about it before. If you want to use an object that has a type from another class that have this inheritance relationship, it should be either from the same type, like where you are calling this method, like here, for example, you can have undergraduate student equal new undergraduate, like we do it before, or it can be it's super class. You can't do it like this, which means that we created a graduate student from here, and then we said this graduate student equals student 2. Even though student 2 was used using a constructor, let's say, from a graduate, however, it is from type student. So a rule in polymorphic assignment, the right-hand assignment should be subtype of the left-hand assignment. If we are not talking about the same type, but the same type, it's okay. I said undergraduate student equal new undergraduate there. So we talk about polymorphic assignment that you can have that's having another type and assign it to another type. However, if it is another type, should be from the upper class or the super class, not from a child one. Why? Because this is normal, because when you talk about A extend B, so if I will go to B type object type B equal new A, this can be okay because A will has all what is B has plus some additional. So if I create a type B, I create an object from B, it can has all B plus additional that it will take it from A. However, if I create a type from A and I said it is B in this case, however, it will have some attributes that are not defined in B. So this is why the polymorphic assignment said there is a restriction that if you want to have different types between what you are creating it and the type of the object you are using, it is a must to have the right-hand assignment is a subtype of the left-type assignment. Good. If there is a solution to do this, yes, we can make something, we name it casting. Like here, we make downcasting, which means that if you want to make a student 3, student 2, so in this case, student 2, which is here, type of student, we make a casting to it as a graduate. So you can make a type casting, which we name it downcasting. So this type object from the superclass, now we can make casting to be in the same level as the child class, and now it will be okay. We will not having any problem using this casting in this case. However, again, suppose now if you go ahead and make, let's see here, student C graduate student 2. So student 3 graduate student 1. Don't be confused. Again, maybe now somehow it's not easy to see the whole image. I will repeat it. So we will have student 1 and student 2. They are both from type student. And don't forget student, graduate, undergraduate. So if we will go to assign student 2 as from upper class to different objects from the lower class, it's okay. Here, if we will go to assign from the child class object type to the upper class, it will have a problem if we don't make a casting. So this is why we will make a casting for student 2. By the way, student 2, if you remember, it is from graduate. Student 2 is from type student, but it refers to an object instance from a class graduate. So when I make an instance I make a casting for graduate, it's perfect, it's okay. Let's go to this example. Student 1, type student. However, student 1 will refer to undergraduate, not graduate. So if I will give it to graduate student 1, so in this case, for compilation, it will be okay. However, for run, we will have an exception in this case, because student 1 hold an instance of undergraduate. So in this case, you should make it undergraduate. During the compilation, when you compile it, you will not have an error. Here, when you compile it, you will have an error. Here, when you will compile it, you will not have an error. You will have an error during the runtime. So you should take care for this. It should be undergraduate casting for this. The point from this, just I want to talk about casting and polymorphism to take care about that. To sum up about what I said, that when you have this inheritance, you can use the type of the superclass to refer to an object in the child class, no problem in the runtime and the compilation time. However, if you want in the other way, you should take care for the casting. And the casting should be the same type from the object instance that you are creating or refer to it. Because many students, they doesn't take care for this when you talk about different types during polymorphism usage in Java inheritance. So like here, if you take a small, the last time we talked about DCD, but just a very small example now again. So if we will have, for example, here, course, we have student, undergraduate student, we will create first the course one as we have already done and go to see if there is another association to it. And we will go ahead and make the different function for this. And then we will, during when we call this method, since it is from course C, and then course C when we talk about enroll, it take a student S. So in this case, student S in course C can be undergraduate or graduate, whatever it is, based on what we have already discussed before. And for sure, and since because we use a student here, because we said it has a student, so in this case we can use any one of assignment from this student, but we should take care about what instance we are using in this case. And since we use a type of the upper class, so there is no problem. So the superclass object type, you can use it in any child class without any problem concerning this. So this is about polymorphism. This last part about interface that we talked about it now. Is there any point concerning polymorphism? Go ahead and ask me. It's good that you know about this, even though you know about it. Are you okay with polymorphism so far that we have already discussed? Give me 2 thumbs up to continue. Someone G1? I need other thumbs up or I will stay here. Okay. Thank you so much, Polkit. Okay, so based on our discussion, we said that Java doesn't have a multi-level inheritance, which means that a multi-inheritance at the same level. Like the diamond we talk about, so A can't be inheritance from B and C at the same time. So in this case, A will inherit B and B can inherit C, but we can't have it in Java. And I said why? Because if there is the same method with the same signature and same name being defined in B and in C, so A, which one will inherit? And there will be a confusion in the child if they have these 2 classes will have the same method and the same signature. So it's not like when we will have a single inheritance, so it can take the method signature and make an overriding for this. But in this case, if you will have 2, then there is the same method from different classes, you will be confused which one to use in this case. So one of the points that we can use interface. So the difference between interface and a class, that interface in all the methods and the variable will be abstract. It's not like an abstract class. Abstract class, we talked about it last time. Abstract class can have some methods abstract and some methods not. It can have. However, in interface, it is a must that all methods and variables are abstract, which means that especially also all methods are abstract. In this case, there is no implementation, and later you can make implementation using different classes. So we define interface, and then we make a class implement into it, and then we'll give implementation for a predefined function with a different based on a function definition and signature. So an interface can encapsulate, as I said, abstract methods and constants or variable to provide no implementation. It's not like abstract class. So we have a class, abstract class, and interface. Abstract class, it's somehow in the middle. It can have some implementation, it cannot have, so it depends. Interface, no implementation, can extract other interfaces also. Classes that implement interface should provide implementation for all methods declared in the interface. As we said now before, based on the with Polkit and the Samaranjit discussion we did it, Java allow only single inheritance for class extension, but multiple inheritance for interface extension. So here we can see here another example, like my iFace and client implement my iFace, and then we can create this in different object, and then we can call the method that is already being here implemented in this case. As we said that here we can use, for example, here in this test phase, this is another class that we use an object from this class, and then we can use it to call this method based on this implementation that we have already declared here. Here another example about multiple interfaces. So you have interface student, interface employee, and then you will have a class full-time student that implement a student and implement at the same time employee. It's like we said that this diamond problem in the inheritance cannot we have it, but here interface we here in this case full-time will implement a student and also will implement employee at the same time as we see here. So in this case we are using the code, which means that this method that we have already defined is the interface. We can reuse the code in different places, and we'll have different implementation based on the environment or the requirement based on the design that we should have already done it before we start this implementation. So we can do it as one here, a multiple, rather than go ahead and implement student. We can do it at the same year. Go ahead, public class, implement the student, as we are saying. So, and later, when you create an object from this, so it can be viewed as a context in student or employee based about the context where how you use this instance. Somehow like what we have already done before when we talk about when you have a different extension, when you talk A, extend B, B, C, or you have different method implementation. So based on the inst context, later you can know about what you are talking about. So we are done from the OOP. I'm sorry that maybe I go somehow more detail. Again, it was out of the scope of the course about OOP programming. But after I have already discussed with you the classes, how we can design class diagram, design, you go ahead and do it as a code. Just I feel that I should give an overview about refreshing and be sure that most of you understand the concept about OOP. And if you still have any question for folks that they are going to watch this video later, go ahead and drop me an email or join me at the virtual office hour. By the way, I will be giving an OOP course next semester, but maybe it is not in your level. It is you have already. You should, based on the plan of your plan, you should have already finished this. So what we have already discussed before, that we have two main points, that we have a design class diagram and we have a state chart diagram. We talked about how we can transfer the design class diagram, and we talked today, we emphasize more about the OOP, that we will use it to transfer the design class diagram with all association, all aggregation that we have done it to create different classes and to define different methods. So we have another deliverable from the design that we should consider implementation, which is a state chart. So state chart, the design class diagram will give us what different classes we will have. And maybe there is an object diagram with it, so I can understand some behavior from the object from different instances, from different classes. And I can know what is the association between different classes and what is the aggregation we will have and what is the multiplicity. And based on this, I will create different classes and define different methods. However, there are the life cycle or the object behavior for a special class. This object, what is the different behavior? So the state chart will give us a detailed view about the whole life cycle of this object, to be sure that the different states of this object we have considered in our class implementation. Sorry. This is what the main aim from the state chart diagram when we talked about state chart diagram during this course. So again, you should have already finished the class diagram implementation. So I expect that all of you have already, based on the sequence, you should already define all the classes and define different methods and different multiplicity that we will have it, and different inheritance and different subclasses based on the design class diagrams we will have. But you have to double check that, do you have already covered the whole life cycle of the object instance for different class or not? Who will tell us about it? Who will tell that we have already considered the whole different states and the object behavior? This is what the state diagram will tell us about it. So this is why one said at the beginning that the two main deliverables from the design that you have to consider when you go to the to implementation, it is a design class diagram and state chart diagram. But you can't do this if you don't start with the use cases and use cases, and then you start with the design model, and then you make the interaction diagram, the sequence diagram, and the collaboration diagram till you will reach the optimal design class diagram and the state diagram. So let's go ahead and see how we can do this. So implementing the state chart, if a class exists, so there is a class should be exist. This is why I said you start with the class diagram and finish with it, then you go to check the state diagram. So you have an account class. By class, you have already finished the implementation for this, and you should now consider the state. I have a question. So this is the state of the object of this class. Maybe that we have already implemented the class and we have implemented different attributes. Like, for example, we have a class account, we will have different account holder names, account balance. This is different attribute that we have already maybe defined it in the class diagram before based in our class based on design class diagram. However, the object states, how we are going to add this to our implementation. This is states. Do you have an idea? Prabjot, how are you? Are you here?
Hi.
Yeah, we miss you. Tell me, you are safe? Everything okay? Do you live in the Fraser Valley? Where do you live?
I live in Surrey. It's all good here.
Okay. Maybe you have a shortage in the supply now.
Yeah, I know.
Yeah. Yeah, that's good. We here, no, our time was more tough comparing to Surrey here, but all okay now.
Yeah.
So go ahead, Prabjot. Have you already heard my question? What I was saying that
About the states.
Yeah. So how the state we can see them in the implementation? Where we can see the state? Where we have to add them in the implementation? I said that suppose you have already finished with a design class diagram, and you are done with the different attributes. For example, you have a class account, you have account balance, account holder name. This is attribute, and you have different methods. So now you want to add the states of the object to this class. So how you are going to add the states of this object, which is like here, any credit, overdrawn, suspended. They would that. Go ahead.
So right now, I do not have any idea how we would do that, but probably like changing the attributes and vice methods, I suppose, but I'm not sure.
Well, yeah, you give me half of the answer. That maybe just the state will be an attribute. You will have more attributes in this case. So the state, they are more attribute, and if there is some operation that they are related to the state, you will add more operation. So suppose, yeah, go ahead.
Or no.
Go
So
ahead.
other class, or I don't know how.
No. We said that according to what we have already defined, that when we start with the implementation, we have two main deliverables that we have already finished with the design phase: the design class diagram and the state diagram. So design class diagram, we have already talked about it, how we use a design class diagram, what different implementation we have to do. For we have already implemented different classes and the inheritance and the association and the aggregation. All the design class diagram details we have already transferred to different classes with different attributes and different methods and different inheritance. This is what you have already done before. Yes?
Yeah.
And today, before you come, we have already talked about, just make an overview about OOP. I said I repeat it many times today that I want to be sure that you are familiar with different technical terminologies about OOP. But still, so there is a small part about state chart diagram, because state chart diagram, the detail in the state chart diagram, how it will affect our code. So now using design class diagram, we have already defined different classes, different instances, different subclasses, and different methods and attributes. So state chart diagram, it normally when you talk, Prabjot, can you help me more? Prabjot.
Yes.
So why you need state chart diagram, even though it is a question from the last lecture? What is the main aim of state chart diagram? Why we need it in the design? Why we have already done this?
I suppose because we need different, like we need to show different transitions our object is like would be going through in the whole like system. So
yeah, you are correct. So state chart diagram will give us the life cycle, the object instance for a class. So what is the different states that this object will have it, in order to be sure that we have already added this to our code. So a class is being already implemented, and you can create an object instance using different methods. So state chart will give you a good image about the different transitions and states that when we talk about for an object for a given class, which is an instance. By the way, what is the main aspects in state? So we will have states. What more we will have in state chart, Prabjot?
we will have the properties the object has.
No, properties of the object is already defined within the class itself, in the class diagram, design class diagram. But we for example, in state chart diagram, it doesn't talk about the properties of the object, because we have already talked about it in the class diagram. We talked about the states, the transitions. Can you tell me more about the transition?
Like transition, for instance.
Yeah, what the transition, what would it include, based on what we have already discussed before about state chart?
Maybe some event, like it'll just change.
Perfect. So it will be more about event and action, if you remember. So we will have different event, and based on this event, we will have an action. This is a transition. And then we will have somehow for the state itself an entry and exit, which means that what is the activity that will be done when we enter the state and or when we leave the state. So this is, we have to add it to the already classes that we have already implemented. So the implementation step will be for the state chart after we finish the design class diagram. First, we have to define a state, which is at a constant or at a variables. So different state we will add more variables to the class that include different states that we will have. This is the first point. So the initial state of the object when be created, it should be part from the constructor. So the constructor method, we have to add it the initial state, which is the value for the initial variable that we defined as a state. And for each implementation, for implementation of a method, we will have something like switch case, because based on what we know so far in early programming courses, switch will give you different status or different value for the same variable. For our case, then we can switch between different states for an object. We have to add this within the methods in the class, because a class will have an attribute and methods. Methods talk about the behavior of the function. So if there are some methods that will affect the state, so we will add some switch case to this behavior method, and we should have already add the states as an attribute in the for this class to be for different instances from this class. Plus, the initial state will be part from the constructor in this case. This is the three main implementation we have to consider. Maybe, so this is, we have to consider at the definition that when we are defining the class in this case. So returning to the account method, we can add the different state at a different variable like here. So in this case, we add here, we here incredit, overdraw, and suspended. And we can give it different values as we can see, which means that because the values will somehow give, so if any credit equals 0, we can understand this is a state for this. So we define it as state, and then we will add the initial state within the constructor of this class. As I said, maybe this account class we have already defined it, but we are now adding more detail about it. So this is, we have finished it. This is, we have now what about this, which means that adding switch case for different method in this case. So here, so according to the state chart that we will have here, so take this partial state chart or incredit. So it will have here this method withdraw. We added as a switch case for this. So case incredit, what we have to do, case overridden, if something we have to do, case we have suspended based on the switch method. Again, doesn't mean that state chart talk about all classes. So some classes will have a state chart, some classes maybe don't have state chart if we don't have different state for the object instance. So if a classes have already a state chart included to it about this, or different classes have this state chart, so we have to consider the state chart when we are implementing the class, like I'm doing now. So in this case, so I have to add to the behavior the switch case that talk about different states and what we expect during this state. What we expect, which means that what is the action. When we talk about action, talk about behavior, I talk about method. In this case, according to Java programming, what we are doing so far. So sometimes we will have a composite state, if you remember, like suspend. So it can in this case, so this state will have another different substate if it is a state, but however they are if you remember that we have some composite state when we talk about state chart. So in this case, we have to create a method, talk about the main state, and then we'll go to the switch case state within this composite method, based on what we have already defined before about state chart diagram. History state also can be stored within leaving the composite state, because based on the composite state that has different state, we will have a history. Also, we can add this to the method, a method that talk about this, the exit from this composite state. Also, if you remember that we talk about enter and exit. And we use more about the activity, which means that enter and exit will not be based on an event that happened and based like transition. Transition, there is an event, then you will have an action. However, the enter and exit action or activity, it's somehow more related to just whenever you enter to the state or when you leave the state. So in this case, we have to add to this case, for example, like here, before we will go to the state, what is the method? Because an action will be a method. And when you will leave it, what will happen in this case? So, like we do here. So, this is about state chart diagram implementation. It's easy. So, to sum up, we start with a design class diagram. And some design class diagram will have an associated chart diagram. What is a chart diagram? What we have already said, it talks about the different state and transition of the object instance from this class. So after we implement the attribute and the method, we have to go to check the state chart diagram and see what's more attribute we have to that as a state, and to add the state to the different functionalities that have this class to be sure that we can catch the different state of the object at an instance from this class. Today we talk about inheritance, polymorphism, polymorphic assignment and typecasting and interface and implementation of the state chart. I hope that it was very clear today. And if people who are here, if you have any question, go ahead and ask me, or maybe I will ask you. And by the way, this is somehow we are finished with the analysis and design, how we can transfer it to implementation. So the next time, maybe I will sum up the course. Maybe we will add something about testing, something like this. Not quite sure about it, but however, the main course, of course, we have finished it. So the next lecture we will have to summarize it, and maybe I will talk about I will give an overview about testing, maybe. But the main course, of course, we are done. So the next lecture will be summarize of the course, plus the last week it will be an open stage for project, as I said. Concerning the final, I will start now preparing the final. I haven't started yet. I will prepare now, start maybe this week or the week after, preparing the final exam. It will include the whole lectures. So it will not be restricted to a special lecture. Maybe by the last week, maybe I can discuss more about the exam structure with you. But so far, you should know that the final exam will include all the lectures. And it can have multiple choice questions, true, false, and also it should have a real case scenario similar to the assignment. So it will have comprehensive. I haven't started with the final exam, but this is what is in my mind, that to have a comprehensive multiple choice and true, false like the last assignment, and to have some questions like the assignment before. So people who have done their assignment and their project and all the material they are reviewing in the lecture, so I'm quite sure 100% they will have a high mark and high grade in the final. The final date and time I have already also published it. Prabjot.
Yes.
Do you have any question for me?
Not specifically, but about the finals. If there will be some diagrams in the exam.
Yes.
Then...
I haven't started with it, but I'm planning to have some diagrams. Yes.
Okay, and then I just hope we would have like enough time, because sometimes you can like think about the diagram itself, but it takes time in the drawing.
Yeah,
So
I understand you. By the way, I will double check. Sometimes, yeah, you don't. Maybe you can use handwriting and scan it and upload it with a document. Maybe I don't know if they have something like this in Blackboard. I will double check.
all right.
If in the Blackboard, because you are going to make the final exam about it using the but I'm quite sure that yeah, we can do it like something like the assignment. So maybe if you use handwriting, maybe it will be easier, and you upload it within the exam. Do you agree?
Yeah.
So I'm quite sure it's okay for me that the easier one, but don't worry concerning the timing of the exam. Normally, when this is the first time I give you a course, but for me, the criteria that I'm using in final exams like this. After I finish preparing the exam, I will go to solve it as if I'm a student. And I believe that normally, if, for example, the exam take with me 2 hours, then I will give students 3 hours. So I will estimate the time that I will give 30 or 35% more time compared to my time when I'm doing the exam. So don't worry about the time, which means that if take 2 hours, it means that's 3 hours for you. If 1 hour have means 3 hours. I think you have almost 3 hours for the exam.
All right.
So don't worry about the time. I will consider this. No worry about it, and it will not be a huge question. Somehow very specific, small amount of requirement if there is a diagrams to do it.
Okay.
But I can't believe that you should have only multiple choice and true false comprehensive. If to be a good exam, I should make an assessment about how you understand the concept and how we can draw diagrams. Because diagrams drawing or sketching was the main point in this course, because we talk about design.
Yeah.
Maybe I will share with you some hints in the final exam in the last lecture, which means the week that we will present the project. And I'm quite sure from now till this week I should be done with the final. So I will have more clear image about the final. But so far you should know that it will include all lectures. It will have a comprehensive question like multiple choice and true false, plus you will be asked some very small real case scenario to give a sketch or draw for this in this case.
Okay, thank you.
What about the others? Do you have any question for me today? Polkit, Janvi, Simranjit? Okay, I want to sum up and finish the lecture today, but I'm asking about the project. Have you already started with the project? Can you tell me? Simranjit? Are you okay with your team and you start communicating, Samranjit? Are you still here, Samranjit? Okay, Pulkit, are you here still?
Yeah, sorry, I
Go
got
ahead.
disconnected.
No. Go ahead, Samranjit. Yeah, you can add later, Pulkit. Go ahead. My question, have you already started with your project with your teammate? Samranjit? I'm talking, yeah.
So no, we were supposed to meet today at this time, but then we had a class. We will meet after this class.
Okay, good. Take care for the time, yeah, because time is flying and you have to catch the deadline.
Yeah.
Pulkit, what about you?
Yeah, we were able to contact each other. So most likely we have already started the basic ideas. We haven't emphasized anything like more specific, but we have already decided what we will be working on. It's
Okay.
just we have to start our like drawing diagram, start brainstorming on that before we run out of time. So that's nothing serious. Most likely we will start Wednesday. Like we'll Zooms or technology, or if we want to meet up, we haven't. We'll probably do that with our group.
Perfect. That's good. You are on a good track. What about you, Genevieve? Are you here?
Yes, I'm here. We have started discussing about the project. Like we have switched from emails to we have made a WhatsApp group, and we have started discussing about like who's gonna do which part, and we are ideally thinking about just a second. So we were thinking about doing the that crime
No,
the
no, it's okay. We don't have to discuss the topic. Just I want to be sure that you have already started with communicating and you are on the good track that you can communicate with each other, because I received some email from some students, they have a miscommunication between each other. So that's good. You are all on good track. What about you, Prabjot?
Yeah, so our group has meted once and will be meeting tomorrow for the second time.
Perfect.
So we are communicating and divided some of the work. Yeah, it's going all right.
Okay, I'm very excited to see the output, especially this such kind of courses, analysis and design, talk about more about what you have already understand and how we can apply this to real case life scenario. So I'm very excited to see your output and to watch your presentation. Either you will make it live with me or you will make it offline with each other and you will share with me the video. Okay, guys, thank you so much for today. I like it. We missed the last week, but it's good that we can do our live session today. I want to thank you all who joined us today, and I wish you a very nice day and hope everything will be okay with all of us and you will stay safe. Take care all. Like always, need 2 thumbs up to live.
Thank you.
Thank you so much. Okay, bye-bye. Take care.